Hello everyone, welcome to this new TouchDesigner tutorial on parametric equations. In this tutorial we're going to see how to make this shape. Its name is Bicorn and we're going to do it using chops, tops and Python script. So the equations for this shape or curve, the parametric equations are these ones, and clearly we can see sorry, that it's maybe an visually easy shape than the ones that we saw before, but it involves more complex equations. So we're going to implement them in TouchDesigner. Last thing before we start, yeah, I don't know how much this is true, but I think that this curve has its name because it looks like this hat, this bicorn hat. So if you know the reason that its name is bicorn, put it on the comments section. So okay, let's start. I'm going to attach a file in the description of the video that is like this, and we're going to start from here. Also, I put this screenshot of the equations so we can see here in the network if we click view on the top, and we don't need to bounce back to the page to know where or what is the next step of, of the equation. So let's start. First, I'm going to put a constant chop. In this constant chop, we're going to declare our parameters. We need to remember that our first parameters is the amount of samples that our code will going to have. And the next parameter is the constants that are multiplying our functions. And we can see that we only have one constant, that is the letter a. So we will declare it, and we give it a value of 1. Okay, after this we're going to put our parent chop, and we're going to change our parent to ramp. We're going to make active the constant, and we're going to drag it the parameter samples to length. And then the last thing, well, the next thing, we can name it t. We're going back to parent page, and the last thing we're going to do is we going to give the value of the cycle. So I will bounce back to the parameters page, because we can see after all these equations, we can see that these equations are valid for a cycle or value that goes from minus pi to pi, and to, or p. I don't know how is to say, how 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 is said in English. And as my native language is Spanish, we know it as p. I think it's the same. I don't know. So our cycle goes from minus p to p, and the last or the past shapes we did, the cycle were going to pi to p. So this is a new range for cycle. So knowing that, here on the range that goes from 0 to 1, we need to go from minus p to p, and this is our new range, and we have by now this value of t. So for not making a lot of connections and getting confused, I'm going to use now on these complex equations and select chops, so we can see clearly the part we're doing of the equation. So first I'm going to make the functions we're going to use with the function chop. We're going to use sine. For angle units, we need to change it to radians, and we copy and paste the function, and we just change the function to cosine. So we have the two functions that we see here. Now I'm going to first make the x or dx function that is very simply. So I'm going to use select. In the select, I'm going to drag our constant, and I'm going to select the channel A. I'm going to put another select, and in the select I'm going to drag the second function that is the first function that is sine. If we get confused, we can rename them. So this is sine and this is cosine. So I'm going to drag it to this second select, and I'm going to put or select t, and we need to multiply them. So I'm going to put a math and connect the two selects, and on combined chops we change the function to multiply, and this is our function for our position in x, in the x-axis. We also can change the name here, so we don't need to rename, and we can save one operator. So from now I'm going to say to rename it to tx, and basically this is the x function. So the interesting part comes from the y-axis. As we see, we use cosine squared and some sums of constants and our functions. Okay, so the first thing is I'm going to select again, or maybe I can copy this one because it's selecting the same constant that we want, and I'm going to change the name to ty for now. So, or maybe to a, to get no confused. So we need to multiply these values for by cosine cube. So, cosine squared. So I'm going to add another select, and I'm going to drag cosine. Then I'm going to connect a math, and I'm going to connect the cosine selected again. So the last thing I'm going to do is to multiply all of them, and combine chops parameter we change to multiply. And for now we have this part of the equation, and as we are multiplying this expression, we can do it also in the same math. So we can again save one operator cooking, and to do this expression we are going to use a new operator that we didn't use in the past tutorials. This operator is the expression. So as I'm using cosine, I'm going to put this in the input, the cosine selected in the input, and basically what the expression chop does is that it performs an expression that you put here and outputs the value of that expression. So the default expression is the input value. So when I connect it, the value that I connect is the output value. So as we see, our expression here is 2 plus cosine of t. So I just need to type 2 plus, and the input val is the cosine of t, and we have now this expression done. And as I said before, we need to multiply by the first expression we did, so we can do it in the same math operator, and we have our upper part of the division done. So the last part, or the lower part, sorry, we can do it by putting another expression. And to get not confused, I'm going to add another select, and I'm gonna select now the sign. So I didn't do this in the Spanish tutorial, but I'm going to see if it works. And basically, if it works, I'm doing here squaring the sinus. So also here I save another operation that is the math operator, and now I can just type 3 plus the square sinus, and this is the lower part of the division. So now I need to perform the division, and we do it with a math chop. First, I connect the value that we're going to divide, and then I connect the value that is dividing the first value. And on combined chops, we change to divide. And basically, this is our functions. So when we have all the equation, we can go back here and change the name to ty, and we avoid using a renamed chop after this. So the next thing is to merge our functions so we can have them in just one operator for making the exporting. Also, we need to add the TC channel, and we can do it by copy pasting the parent chop. If we click right click the to range parameter, we click preset parameter, and our expressions are gone. We change the type to constant, and the amplitude to 0, and finally on channel name or channel page we change the channel name to TC. and we connect it to the merge. Finally, we add a null and we connect chop2, and we see that we have here our Bicorn. So that was the implementation with chops. Next, we're going to do it with tops. So for the tops part, we're going to add a ramp top. In this ramp top, we need our resolution in X to be the same number of samples we declare, and on Y we need to set to 1. Lastly, change the pixel format to 32-bit float RGB. Okay, so if we remember, for now we have our ramp that is the same as here from 0 to 1, and we need to convert them from -p to p. So I'm going to add a math top, and on the range page we're going to type -math.p to math.p. If we remember, R is for X channel or X-axis, and G is for Y-axis, and B is for Z-axis. So I could type here the expressions again, but I can save it by clicking right clicking on the range and copy parameter, and right clicking and paste expressions, and all expressions are pasted now. And for Z-axis we don't need any value. So now we have our ramps going from -p to p. The next is we're going to make our functions with the function top. Here we can do it separately by channel, so this is helpful as we don't need to add lots of operators for the different axes. So for R, that is X, we need sine, and for G, that is Y, we need cosine. And for function B, we need a constant value, and our constant value is 0. And don't forget to change our angle units to cycles. Sorry, to radians. Okay, so next part is we're going to make the equations for the Y axis, because our function on X is the same that we did here, so we don't need to make any more computation here. So I'm going to put first, I'm going to put a math. This math, I'm going to make a channel pre-operation of square. So here I'm squaring all the equations, but I'm only focusing on cosine. Okay. And the next thing, sorry, I'm going to set this aside. Okay, the next thing I'm going to do is add another math. And in this math, I'm going to pre-add the two value we have here. Okay, so by now I have these two equations or two functions done. The A, we're going to leave it to the final step. So the next part is to add a multiply, and we have the upper part of the division. Okay, so the next part I'm going to add a reorder because I need the value we have on the R function. I need it to be on the G function, that is the computations that we're doing here. So we need to make this with a reorder, and this reorder is going to have input 1 to 0, output of blue 0, output of alpha 0, and or on output green we need to change from green, that is cosine, to red, that is sinus. So here we have on our red channel the sine function, and here we have the cosine function on the green channel. So now we just need to add math again. We make a pre-operation that is square again because we need a square, and finally we need to pre-add the value of 3, and we have now our both parts separated. The next part or the next step is to make the division, and the division we can make it with a composite top. We connect the both results and change operation to divide, and this is our final result for the G channel, that is the Y axis. And the last thing we're going to do here is to make both well, also here it's doing these operations for every channel, but we don't need this operation for every channel because our curve will be different. So we need to add another reorder top. We're going to put in the first input the function where is the sinus on R, and the second input we're going to put the Y function or the G function. Finally, here in our final output we need to leave here this Caesar because S is the sinus of t, and our output green we need to put the green value of this composite, that is the division. So finally here we can see that this is our final top with the correct functions. And the last step, as the A constant is multiplying both, we can do this operation, or we can leave this to the final because it's like scaling the curve, the equation. So I'm going to connect after the reorder a math, and on multi-add I'm going to drag and drop it to the multiply parameter or um, parameter A, and this is the final results. So to visualize it, we need to add a null. This null, we need to convert them to chop values, so we connect it with a top2. We change the name to tx, ty, tc, and alpha we delete it as we don't need it. And finally, we change our chop information to sub information, and we see that we have again the Bicorn curve. So this was the part for doing it with tops, and finally we will do it using the Python script, and I'm going to open this on an external editor, and this is the oh sorry okay, sorry. So this is the preset file for our equations, so we don't need to type again and again some basic steps that we do every time we use scripting. So here, our first thing we're going to do is to declare our parameters, but they are declared by default because it's the same parameters we've been using on the past tutorials. So we can go to the next step, and also we don't need to use for now the polar parametric equation function we implemented on the second tutorial, so we ignore them. So first we're going to declare the variables. So we do it by putting the name, and we're going to name it samples. The variable samples is equal to script up punto par punto sorry dot par dot samples. The next value is a, and this is the same, script up dot par dot a. Oh, sorry. And we don't need to forget to declare our cycle value. For NOR, our cycle goes from 0 to pi to p, and we declare it cycle equal to math.p, and we save it. So when we save it, this expression deletes its error, and finally we can see that the channels that we are appending here are visible here, but right or now the samples are set to 0 and our a value is set to 0, so we need just to export them for our constant to samples. I prefer to use the reference and a to a, and now we can see that the script or the parent have the length we declared here. So going back to the scripting, the next thing is to calculate when the next thing is to assign the samples to the script, and then we need to calculate the step size. So as we're going to from minus p to p, it's basically doing 2 times the value of pi or p. So we just need to introduce the value as to pi, and we will have the same output. So we're going to declare step is equal to 2 times our cycle divided by the length of our samples minus 1. We need to remember that we do this because Python starts counting from 0, so we just need to extract 1 for a total number, and our step is done. Then the output channels are appended, and finally we need to assign the values to or for every sample of every channel we declare here. So we're going to do it for tx and ty, and tc we need it to be 0 as this is. So we do this using a for loop, and we're going to make it with a range that a total number of samples. This for loop, first we're going to calculate our angle, and our angle is the value of our cycle times the number of sample we're in that time. So okay, that's it. I save it, and then we're going to assign the function for that specific index, sample index. And for tx, if we remember, I'm going to put this here to see our equations. For x, we need our value or constant a multiplied by math.sin of angle. Sorry, here I made a mistake. Here I need to put the value of our step, and we now have the value of the sign function on the tx channel. Next, we type ty of the index is equal to this will be more complex, so I'm going to use more parentheses. So the first one is a times math.cos of angle, and this needs to be squared. Okay, here I have a mistake, it's cos. Okay, so we have for now this part. I'm going to add another parenthesis, and I'm going to multiply by 2 plus math.cos of angle. And this whole expression needs to be inside parentheses because we're going to divide them by our next value. So I'm going to the parentheses here, and 1 here. And then after the last parenthesis, I'm going to add a slash and another parenthesis. I'm going to type 3 plus math dot sine of angle squared. So we have now the function. So here you can see that the null is already connected, and I'm going to put or attach the chop to sub, and we see that the curve is the same, no? Or but we see here that the y value is shifted. This is because we're using from minus p to p, and here we're using from p to 2p. So we can leave it here and we have the same value, but if we want to be the same shape for the TY channel, we need to shift our values, and we can do it on the next, or with the next, I mean with the next expressions. So I need to add after the for to add an if. So we need to divide our number of samples in the middle. So if our samples, or if our current sample is less or equal that our sample value divided by 2, that is the middle of the samples, or angle, I can put here, will be equal to the step value, but we need to multiply them by minus our number of samples divided by 2. That is, if we have, for example, 100 samples, we're going to go from 0 to minus 50, and we add the current sample. So for the first sample, our samples is minus 50, and we're going to add 1, so we're going to have minus 49, and the next sample will be minus 49, and we add 1 and will be minus 48, and so on till we reach to 0. I hope I explained myself well. It's sometimes easy to explain for me these things, but I will try to improve that. So that is for the first 50 values if we have 100. And as we can see here, the shape is having the shape we have on the other ones. We need just to do this same conversion to the upper part, or to the last output channels. Also, we can see here that the first part is well viewed here. So the next thing is to add an else, because if our samples are way bigger than the middle number of samples we have, we're going to perform the next operation, And this operation is, or angle, is going to be our step again, and we're going to multiply now. For our samples, we're going, or the real value for the samples um, we're accessing is 50 to 100. So we need it to be from 50 to 100 to be from 0 to 50. So we have the pi and no 2 pi value. So for now, as we are accessing on 50, we need to have the value of the current sample, and we need to rest the value of our middle samples. So yes, that's it, and I'm going to save, and our final shape is done. So basically here is we're going to start from 50, and we're going to remove 50, so we are on 0, and the next is 51, and we rest or subtract 50. I should say subtract 50, and we have 1. Next value is 52, and we subtract 50, and it's 3. So and on, and the final value is 100. We subtract 50, and we are on the 50 sample. So going from 0 to 100, we make the conversion from going from -50 to 50. And now the shape is the same for the 3 parts of or 3 families of operators. So that was it. I'm going to close these equations, and now I'm going to use this information to make a simple animation. So I'm going to select chop, or null tree. I'm going to work with chop values. I like it more for these shapes. Okay, I'm going to go to Geo, and I'm going to turn on instancing, and or select. I can change the name to pose, and I'm going to drag it to translate up. So tx, ty, and tc, and we have our circle here instance. Also, we can change here the scale, the overall scale for every sample. It depends of your choice, so I'm going to leave it by 50. The next thing, I'm going to add color. So when we have the animation, we can see that the how the animation is following the path of the shape, or the instances are following the path of the shape. And I can do this putting a ramp top. This ramp needs to have the same value for resolution X and 1 for resolution Y. And we change our pixel format to 32-bit float RGB. So I will choose colors like the ones I put on the first file that is something like this, the example file. I'm going to the instance page of the geo, and I'm going to draw, well, before doing that, I can change the name to color. Then I'm going to I'm going to drag to color up or color top and choose the right channel for every channel. So one thing I like to do with animations and color is to change the face as the times goes by. So both if we can see that the change here is I don't know how to say it, abrupt. It's going from this to this in just one sample. It doesn't have smoothness. So the thing I like to do and the way I work with these ramp operators is that I drag this upper selector here, I drag it to the middle. So basically having the same color on the both edges of this selector makes a gradient. So as if shift, the colors are chainly like a gradient, so it looks better than these ones. I hope you understand what I wanted to say. So that's one part. I can start doing this with apps time dot seconds, and you see how the color is following the shape. I'm going to multiply it by 0.5. Okay. The next thing is I want to see the samples following the shape. So I can do this by shifting also the face of the pattern. And you can see here how it will do it. So I'm going to type again apps time dot seconds, and you see the shifting, but it's super fast, so I'm going to make it slow, and you see now all the shapes follow, or all the samples follow the path, all the instances. Also we can do it like they follow different directions, so the color is clockwise and the shapes are anti-clockwise. I can change also here the number of samples, but I need to reduce again the velocity, and there that's looking better. Finally, I can add some noise to control the scaling. I copy the expression I have here on the color, put it here on resolution, and put 1, change to 32-bit float mono, and change the name to scale. So now I go back to instance 1 page and drag it to the scale operator and select the same channel for all both scales, all 3 scales, as we need just use 1 value, and we can start again playing with these values maybe something not to disappear this the tinier shapes, and playing with period so it looks more random, more noisy. Offset 2 maybe. And so feel free to play with these parameters. Also, you can change the type of uh, to 3D shapes like a box or an sphere. So we plug in here to the transform, and you see now that the shapes are in 3D. Also, you can change or use, well, no, I need to copy and paste, change the name to rot, and drag it to rotate up, select RGB for X, Y, and Z. I change it to take off monochrome and change the pixel format to 232-bit float RGB. And now we see these rotations. So as our rotations we need 2 degrees, we are doing mm, a tiny rotation, so we can do it like 180 and our offset to the same, so it's rotating from doing a 360 full rotation. And we can also give it some movement to or rotations and multiplied it by 0.1. And I can copy this and put it on the scale, and also the scale is moving through time. And yeah, that's it. That's the tutorial. You can play with all these parameters. The rotations are good for shapes with edges, because we rotate a sphere, we don't see much that rotation because our sphere is equal in all of its points. But with the cubes or the boxes, we see it. That is more, the rotations are more clearly. So I hope you enjoyed this tutorial. It's a bit long, but I think it's worth the knowledge and the math compressions we're having here. This time there is no post for these tutorials because I have time limited, but I will sure go back to post when there are, or when I upload tutorials that need more in-depth explanation. So if you like it, please subscribe and hit the like button, and you will find preset uh, the preset file on the comments, or sorry, on the description of the video. And also I'm putting out this same, or this final one, in the same description, in the same link. So see you later in the next tutorial, and thank you.